we are going to discuss HPS 2019 main question number paper number 2, question number 1. So question number first A, it is given that we have to suppose to find out, discuss the convergence of this series. Now we can write the given series as summation 0 to infinity factorial n divided by n plus 1 multiplied by n plus 2 and finally multiplied by x raised by n. This can be further summarized as x raised by n divided by n plus 2 multiplied by n plus 1 factorial 0 to infinity. So in order to find out the convergence, we are going to use the ratio test to determine the convergence, which states that the limit n tends to infinity modulus of a of n plus 1 divided by a of n will be equal to limit n tends to infinity x modulus n plus 1 n plus 2. So ultimately this is equal to 0. So it means the radius of convergence is infinite, which means the series converges for all value of x. To determine the nature of convergence, we use the ratio test again. We get limit n tends to infinity a of n plus 1 divided by a of n. This is equal to limit n tends to infinity modulus of x n plus 3 divided by n plus 2. So it means the limit once again is 0. So it means this series absolutely converges for all values of x. So it means it is a convergent, absolute convergence for all values of x, which we have to discuss the convergence. So our final answer will be, it will be convergent absolutely for all values of x. Question number B, it is given that examine if the function, this function is harmonic. Also find the complex function f of z in terms of z, where f of z is given by u plus iota v. So in order to check whether the given function u is harmonic or not, we are going to find out if it is going to satisfy the Laplace equation, which is given by the second derivative of u with respect to x, partial derivative, and the second partial derivative of u with respect to y, their summation is equal to 0. So first we are going to do partially derivative u with respect to x and y. We are going to get partial derivative of u of x is equal to 2 by e raised to power 2xy sine of x square minus y square plus 2v e raised to power 2xy cos of x square minus y square. And the second derivative of the same function will be equal to 2e raised to power 2xy sine of x square plus y square plus 4y square e raised to power 2xy cos x square minus y square and minus 4xy e raised to power 2xy sine of x square minus y square. Now we are going to find out the partial derivative of u with respect to y. So this will be coming as minus 2v e raised to power 2xy sine of x square plus y square plus 2 of y e raised to power 2xy cos of x square minus y square. And this once again partial derivative with respect to y again will be giving us the, this will be the second partial derivative. Now we are going to add, let this be equation number 1 and this be equation number 2. So we are going to add equation number 1 plus 2. So we can see that the summation partial derivative, the summation will be equal to 0. So it means u is harmonic. That was the first part. And the second part, we have to find out the complex function f of z in terms of z. We are going to use Cauchy-Riemann equation, which states that partial derivative of u with respect to x will be equal to partial derivative of v with respect to y, and partial derivative of u with respect to y is equal to minus of partial derivative of v with respect to x. We have to prove these two parts. So first we are going to partial derivative of v with respect to y. We are going to get 2 of y e raised to power 2 of x sine x square plus y square plus 2v e raised to power 2xy cos of x square plus y square. We are going to integrate with respect to y. We get v of y comma x is equal to integration 2y e raised to power 2x sine x square minus y square d of y plus g of x. Differentiating with respect to x and comparing with the second equation, we get partial derivative of v with respect to x is equal to 2x e raised to power 2xy sine x square minus y square minus 2y e raised to power 2xy cos x square minus y square is equal to negative of u upon y. Partial derivative of u upon y. Comparing these two terms. Now, using this and integrating with respect to x, we get v y of y comma x is equal to integration 2v 2x e raised to power 2x sine of x square minus y square d of x plus h of y. Comparing with the previous expression of v, we can see that g of x is equal to this function and h of x is given by this function. We already found out that f of z is equal to u x comma y plus iota v x comma y. So we already know these two values. We simply substitute this value and we are going to get the final answer, that f of z in terms of these two variables. Next is question number first C. We are simply going to find out what is the Laplace transform of f of t, which is given as e raised to power 3t u of t minus 2. So this is a simple formula. That is Laplace transform is equal to 0 to infinity the given function multiplied by e raised to power st. This is the given function and it is being multiplied by e raised by st. We already know that u of t minus 2 is equal to 1 for t greater than 2 and u of t minus 2 is equal to 0. So basically it means we have a step up function u raised to power t minus 2 is equal to 1 for anything t greater than or equal to 2. So it means if this is 2, we are going to have this function u of t minus 2 is going to have 1 magnitude, and if it's less than, then everything will be, the magnitude will be equal to 0. So we are going to differentiate, integrate it to be in two parts, 0 to 2 and 2 to infinity. So evaluating the integrals, this is given as e raised to power minus 2s plus 3 divided by s plus 3 plus e raised to power minus 2s plus 3 divided by s plus 3. S plus 3 will be the final LCM and this will be a simple arithmetic addition. Therefore, the Laplace transform of a given function is given by twice e raised to power minus 2s plus 3 divided by s plus 3. Now, this is the last part of the first question. We obtain the smallest positive root of the equation, which is given by x log 10x minus 1.2 equal to 0 up till second place of decimal using Newton-Raphson method. So this is the given equation. Let us suppose that f of x is given by is equal to the given equation. We find out its first derivative, that is f prime is equal to log to the base 10 of x plus 1. So let us make initial guess that x of 2 is x of naught is equal to 1. Then using the iterative formula, which states that x of n is equal to x of n plus 1 is equal to x of n minus f of x of n divided by f prime x of n. If you substitute value of f of x, that is a given equation, and f of prime, which we already found out, we are going to get x of n plus 1 is equal to x of n minus x of n log to the base 10 x of n minus 1.2 divided by log of 10 x of n plus 1. So simply we are going to, using the calculator, one by one we put the value of, first we put value of n equal to 1. We are going to find out x of n, which will be given by this. For this part we are going to put and if n is equal to 2, we are going to get x of 2. For this part, we are going to put n equal to 3, we are going to get x of 3. So from this last two iterations, we can see up till the third place of decimal, or we can see up till third place of decimal, the value is same. We can say that finally the given answer will be equal to x is approximately equal to 1.22.